Now previously we have reviewed the Rham cohomology just for the case of Riemann surface, but that's good for now. And we noticed that this H0, the 0th degree, the Rham cohomology groups, being the kernel of this, it's just a set of this a group of constants, a complex number, so that agrees with the Cech cohomology in degree 0. It turns out that they will also agree in degree 1 and 2, so that's what we're going to show next. Well, to prove this isomorphism, we need to relate these two cohomology in some way. We'll make this Cech cohomology appear by looking at some short exact sequence of sheaves, and then taking the long exact sequence of cohomology. Now we need to choose some sequence of sheaves that somehow is relevant and related to the de Rham complex. So an obvious choice is to look at the following chain complex of sheaves. Observe that these groups such as global sections of these sheaves. Observe that even though this sequence is exact, it's not short exact. It's not short enough. But no problem, we can split it into two short exact sequences, right? We just let K be the kernel sheaf of this D1, so then we get injectivity here. And because of exactness here, K is also the image of this D0, so we get the surjectivity here. And we got two short exact sequences. And as usual, when we see the short exact sequences of sheaf, we want to look at long exact sequence of cohomology. Recall that using a partition of unity, we can prove that in degree greater than or equal to 1, the cohomology of all these smooth sheaves must vanish. So in these long exact sequence, we can cancel these terms. Alright, so this is not enough for us to compare the two cohomology, so let's look at H1. The H1 de Rham is kernel of this D1, right, mod out by the image of D0. Observe by definition of the sheaf K, this kernel of D1 is just Kx, right? And then we are modding out by image of this D0. So this should be co-kernel here of this D0 map. And what's the co-kernel of this D0 map? Well, here, because this vanishes, so then the co-kernel must be this cohomology group. Or if that language of co-kernel confuses you a little bit, then we can also say this. If we call this connecting homomorphism delta, then by exactness here, the image of D0 is equal to the kernel of delta. Right, so this is equal to Kx mod out by the kernel of delta. But then this map is surjective because this is 0. So by the first isomorphism theorem, this quotient is isomorphic to H1 with coefficient in this locally constant sheaf C. Thus, we have shown agreement of the de Rham cohomology and Cech cohomology in degree 1. Now let's look at degree 2. Remember, this de Rham cohomology group in degree 2 is just going to be the kernel of this map, right, which is just the whole of E2 and then mod out by the image of D1, so the co-kernel of D1. But look, in the long exact sequence here, because this vanished, the co-kernel of D1 is just going to be H1 with coefficient in the kernel sheaf K. This group here. But now observe from this short exact sequence, we see that this H1 must be isomorphic to this H2 with coefficient in C, because these terms vanishes, and so we are done. Thus we see that for a Riemann surface X, the de Rham cohomology groups of X are isomorphic to the Cech cohomology groups of X with coefficient inside the locally constant sheaf C.